Starting, all attendees are in listen-only mode.
Can you hear me? Am I audible enough to you? You could reply using the QA window. Hello, everyone. Am I audible to you? Okay. Okay. So, hello, everyone. Good morning to people from India and good evening for people from US. I'm Sandeep and I'll be taking this session. And we have a great set of audience today. Now, a little bit about um, you know, the code of conduct. So all the sessions included this one are get recorded. So and this recorded video will be shared with all of you and presentation will also be shared and this session is open for all and including our the people who have enrolled as well as people who have you know who are just attending it for understanding our mode of training. Okay, so the instructor will speak and you can ask your question by typing. So first of all, a warm welcome to all of you from No Big Data. So about No Big Data, very brief introduction about No Big Data. We focus on expert instructors in their specific domain, and these instructors are generally from their that particular background on which they are teaching. They have been either a product manager or a developer into that domain, or an architect. And we have something called Cloud Labs on which all our students can do hands-on immediately. Cloud Labs is a cluster of computers set up for our students where they can log in and start using the technologies. And we provide something called LMS where we upload all the content along with the class recordings and assignments and quizzes, and the project work is also available and uploaded over there. Now we provide a real life project to the people who perform good in our trainings, and we provide a course completion certificate to everyone who finishes the course, and we provide a 24 by 7 email support. And we have set up something called knows big data, our alumni network, where you can stay connected with others, you stay abreast with the new technologies, upcoming sessions, and all, and also with respect to jobs. All right. So let me go quickly go through your profiles, and then we'll talk. Okay. Hi Prajesh, and we have hi Tarak, hi Murli, hi Shashi, hi Prithvi, hi Puneet. So Prajesh is a director technology at Casines. Welcome Prajesh, and we look forward for a further discussions with you. Hi Lisa, hi Saurav. Okay. Hi Puneet, hi Sai. Okay, hi Venkatesh, and okay. So Sai Charan is working with IBM and having 2 years plus experience. Okay. So please feel free to introduce yourself. Hi Chandra. Ravi is a software engineer. Okay. Chandra is a BI architect. Great. Great to have you, Chandra, in the session. Karthik is from Atlanta and is a grad student. Welcome, Karthik. We have Venkatesh, who is a Unix system admin at AT&T. Great to have Venkatesh in the session. And yeah, AT&T is the one who actually created Unix. Hi Dushyant. Dushyant is working at .NET Technologies for more than 11 years. Welcome Dushyant. You are going to definitely get benefited. Chinni is having 7 years of experience and is from working at CA. Great to have you, Chinni, in the session. Okay. Elizabeth is an engineer by training, and big data falls under her area of interest within my day job as a policymaker. Great, great, Elizabeth. And Lakshmi Kant is from Dehradun. Murli is with IBM, Lotus Domino admin. Great, Murli. Abhilash works as City Consumer Technology as lead architect. Great to have you, Abhilash, in the session. And Shashidhar is working at an analytics startup, Procosia. Great to have you, Shashi, in our session. Okay, and Moru is Java architect and PM. Great. Saurabh is pursuing MTech from National University of Singapore and with 3 years plus experience. Great to have you in the session. And before that, Shashidhar worked at Musigma, Bangalore. Musigma is one of the big data companies. That is good. Peter from IBM, IT manager. Lakshmikant is working at IT manager in Sidgul, having 8 years of experience. Okay, wow. So we have Kishore with 4+ years of experience in Ruby and Rail and works at Sonata Software Bangalore. Great. So we have a very great set of audience today from various kinds of different fields and a great set of experience and the domains. So let's start with and this is a little bit introduction about myself. I'm Sandeep Giri. I did my graduation from IIT Roorkee in 2002, and after that I worked at DE Shaw. DE Shaw is a hedge fund company where we actually used to churn big data. Even in 2000, we had a big cluster of 10,000 nodes, and we had been churning terabytes of data since that time. After Disha, I started a company called Tbits Global, where I built a document management system on the lines of what we have MongoDB today. Then I worked at InMobi. There I built a recommender for them, which where I used to churn around 200 terabyte data. Afterwards, I worked at Amazon, where we built a high throughput system for their website and something on the lines of Apache Storm. And in 2014, last year around April, I started No Big Data along with a couple of my friends. Okay, so basically that's about it. Our current focus with respect to No Big Data is providing the best big data trainings in the industry. Okay. So our extreme focus is on providing the best trainings which our users can take benefit out of. Okay. Now, all right. So today we are going to discuss the basics of big data, and then we will discuss HDFS architecture. HDFS is part of Hadoop, and that we will be discussing in the second half. All right. These sessions are heavily discussion oriented. The only biggest benefit of a live session as opposed to a recorded one is the discussion. So feel free to ask as many questions as you wish. And at the end of every slide, I'll try my best to answer each and every question. All right. So feel free to ask questions, and because that is the main objective of any live session. All right. So starting on in today's class, we'll be discussing all this. Now, before we start, let me start with a question to you. What is it that you have understood by big data so far? You can answer the question using questions window. Prithvi says huge amounts of data. Tarak says that it's big data is something that amounts to large amounts of data. Okay. All right, very good answers. So Murug says that it's huge enterprise data which can provide valuable business insights if used properly. Good. Sashidhar says which might be difficult to handle with traditional tools like Excel or SAS. Good. Large amounts of non-traditional data sets. That's Rohit. And Ravi says huge data that can be easily analyzed, handled by existing tools, unstructured data logs. So that was Ravi. And Prithvi says unstructured logs and feedback etc. So says big data is nothing but doing analytics using huge data. Okay, okay. Pradesh says huge amount of data that is later processed to make three-dimension data. Okay, huge data generated by any system, such as. Okay, that was Chinni, that was Prajesh. And Lalit says high volume and velocity. Great, great set of answers. Great set of answers. And Venkatesh says if it's structured, used for business. Okay, so very great set of answers. So let me summarize what you have said because all of you have said one dimension to the definition. So in very simple words, big data is nothing but a data of very big size. Okay, big is an adjective, data is data, and big data means a huge data in very simple words. Okay, now how big the data? The data that you cannot process using existing tools. And when I say existing tools, it generally means existing file systems, existing databases, or existing tools such as Excel sheet. So you so such kind of data generally you cannot handle with using the existing set of tools. And the data could be structured or unstructured. But most important criteria for calling a data big data is the distributed architecture of the tools that is required. So when you have to handle a data that is so big that you cannot use the usual tools and you require a new set of tools which work on multiple computers simultaneously, then you call your data as big data. Okay, so in very simple words, any data that needs to be processed using a distributed architecture as in a software that runs on multiple machines simultaneously, utilizing the capabilities of multiple machines to provide you the output. So such kind of software is called a software with a distributed architecture. All right. So so this kind of data is known as big data. So as a general thumb rule, whenever you realize you can't handle this size data or using a single computer and you require multiple computers and hence a software that can run multiple computers to simultaneously to give you the output, then you call that you are handling big data. All right, so that is how we define big data. Sounds good. All right. Now, this is the traditional definition of big data, where we say that the earlier there were three V's, then there are four V's. So these V's define the properties of data that make a data big data. So the first property of the data that might make it big data is volume. When you have a lot of data which is silently stored, or you need to store that amount of data, then you call, and because of the sheer volume of the data, you realize that it's not a single machine that can handle such kind of data. You need a multiple machines to handle this kind of data and a software that can run that can run with the resilience, with with the ability to run on multiple machines simultaneously without any problem, then you call that your data is big data because you are not able to store it using a single machine. Okay. And the examples of big data could be Facebook stores 500 terabyte of data every day. Okay. Now the second part is velocity. Velocity means the data in motion. What does it mean? So there could be a scenario when, because there is just too much of velocity of the data, that to handle that kind of velocity you require a distributed architecture. You require multiple computers to handle such velocity. Okay. Velocity could be in terms of when the users are hitting your website, that is velocity. Or if you think about in terms of again Facebook, is every time all the users are refreshing, all the users are sending pings to the your server to check if they have if they have a new request for their, if they have a new change for the new feed. Feed is the news they see, and every second that has to be checked with the server if a user has some new items in the feed. So every second a request goes to the server just to check this. And imagine that a million users connected to Facebook at the same time would would be sending a million requests in a second. Okay. Now this kind of million requests you really cannot handle using a single machine. You require a distributed architecture, or you require multiple computers to handle this kind of velocity. All right. Now, third part is variety. But before I take that, let me take a question. Chandra says, are we supposed to have huge amount of data to adopt big data? I feel big data is process of achieving the things that we are not able to achieve with the conventional system that we have right now. Okay. So basically, Chandra, that is Chandra's question. So what he mean to say is, whether we have big data or not, there are certain things that we cannot achieve using existing tools. And big data is that process. So most of these problems, I mean, say for example, if you have to do analytics, you can use R, and R will work perfectly on the smaller data. Okay. But that's not what we call big data. The moment you realize that you cannot use even the tools like R, and you require a different kind of toolkits which runs on multiple machines simultaneously, for example, a MLlib, or other kind of libraries which run simultaneously, like Spark, which runs simultaneously on multiple computers, then we say that we have the big data. Okay. So the big data is characterized by that phenomena. Okay. So whatever these tools do, the new tools which we are talking about, say we will talk about a new file system. That file system is fairly useless if your data does not grow to a bigger size. Okay. Similarly, the Hadoop kind of system is useless if your problem can be handled by a single computer, and a single computer can handle your problem efficiently and happily, then you don't require a solution like Hadoop. Okay. So that's how it is defined. Right. So Sai's question is, how about the systems working? How were systems working before big data started? How did they handle large amounts of data? Very good question. Just hold for a minute and then we will get into this. It's a very good question. All right. Now, We discussed about two properties of data that might make it big data. One was volume, other is velocity. The third is variety. Variety as in there could be a circumstance when, because of a particular data format, the way you have to process this data, because of that you might have so much work to do that you require multiple computers to handle your work. Okay, so for example, imagine this. Let's take a case where there is no velocity and volume, and still, just because of variety of data, you have to use multiple computers to solve your problem. So one such case is the let's take a Google Maps case. So if you store a data of a country which will be close to 500 gigabytes, 500 gigabytes is not that big a data that we cannot handle using a single machine. We can store it easily on a single machine. We can. It has no velocity, but it's a maps. It's a 3D data. Now, if we have to find a path from one corner of the country till the another, you will have to go through the map. You have to understand it, and you have to do it in a very significantly less amount. Then you cannot find a path in this map from one point to another, one extreme to another, without using multiple computers. Okay, so in this problem, in the pathfinding problem on the map, although your data was smaller, it was 500 GB, half terabyte data, but just because the maps is a complex format and the graph requires a big amount of processing, the problem became big data problem. All right, just because of the variety, the data, the kind of data. So it your data, as of today, in earlier days we used to call data which was always in tabular format, but today when we have videos, when we have music, when we have graphs, when in form of maps, the geospatial data, there are many things which require far more computing than our standard relational data. Okay, so that is why the variety is a big use case for the big data. Now the fourth one is veracity. Okay, fourth one is veracity. Veracity means the the data due to inconsistencies. So there could be a scenario where your actual data would be very small, but because of the confusion, because of inconsistencies, because of lack of knowledge about data, you might have multiple kind of different data sources, different, you have half cooked data, because of which you have got big volume or big velocity or big amount of processing required, right? And say take a case of the temperature data from across the globe. So you consulted five vendors to get you the temperature data from across the globe, and each vendor gave you a different kind of data. Let's say first vendor gave you the data in the form of GPS coordinate and the temperature reading for every second across the globe. Second vendor gave you the zip code and the reading for every second across the globe. Third vendor gave you the reading for um, the few centers in a zip code. They have something called a center ID, where they are giving us the only lesser amount of data second wise. Now question is, out of these three data sets, which one would you trust? So to answer this kind of question, you have to have an understanding of the data thoroughly. You have to have a comparison analysis of these three data. And to analyze this data, because there are three sets of data, your data is tripled in the volume. So to handle this kind of data, you might require a great deal of a processing. So here the confusion whether should we take A set, B set, or 3 set, we end up churning all three just to figure out which one is best. And that's when we say that because of these kind of doubts, we ended up having big data. All right. Yeah. Thank you, Tarak, for that point. All right. So from now onward, so what she suggested that he suggested, I don't know. So what he suggested that is that um, if I could, the examples, if I could type in the notepad. So from now on, if I have to say anything extra, I'll try to use the notepad. Okay. That will be like subtitling myself. All right. So moving on. All right. Any other questions till this point? So veracity is clear to you because generally people have a problem with veracity. Good, good. So Prithvi is clear. All right. For others, is it clear? Should I move on? All right, great. Now, a quick questions to all of you, just to check if you are with me or not. How many bytes are there in petabyte? All right, great, great. Yes. All right. So yes. So all of you are correct. And sort of it's 10 to the power 15. All right. And yeah. Oh wow. Chinny has typed a big number. It looks like he has searched in the Google. All right. So it's actually close to 10 to the power 15 bytes in a petabyte. Better way to remember it is using a table like kilo, mega, giga, tera, peta. Kilo has 1024 bytes and mega has 1024 kilobytes. So each one is multiple of 1024. Okay. So a tera is 1024 to the power 4 and a peta is 1024 to the power 5, which is 10 to the power 15. All right. Okay. Okay. Good. 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 So Chinny uses the calculator. Okay. And moving on. Now, an important question is 1 petabyte data a big data? If you have to do a computation on 1 petabyte data, can you get it done on a single computer in a reasonably small time, say 5 minutes, 2 minutes or so? So, in your opinion, do you think 1 petabyte data is big data? All right. Yes. So the truth is when we talk about you know the most basic thing you do with the data is store it, right? Before even doing any processing, you need to store it somewhere. So can you store a 1 petabyte data reliably on a single machine? Or can you handle 1 petabyte data without having multiple machines? Okay. Yes. Yes. So almost all of you have answered it as yes. Okay. All right. Great. Yes. Puneet says you can, but it will be terribly slow. Good. Great set of answers. All right. And yes, you're right, Tarak, that the traditional databases cannot compute on such large amounts of data. That is correct. Now, so okay, so everybody probably is agreeing with me in this. Now, it's a traditional graph which we talk about the growth of the data, specifically digital storage. All right, so this graph shows that the analog storage, it has not increased much since 1986 till 2007, but the digital storage has increased humongously. Digital storage have sort of exploded. The digital storage have expanded exponentially since 2002, when we call it the beginning of the digital age. Hi. So this graph basically says that in 2002 something happened that we started calling it a beginning of the digital age, and by 2007 the digital storage went to 280 exabytes, which means 3 into 10 to the power 20 bytes. And if you think about exponentially, now it will be far 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 beyond what it was in 2007. All right, so next question is, what exactly happened which exploded the data so hugely? What exactly happened that made the digital storage so high? So the answer is in terms of two things. First is the hardware, second is the connectivity. So hardware became cheaply available, faster and smaller. So and the phones were the most popular hardware which is available to the people. So specifically because of the phones, and because and then and because of the connectivity in terms of the hardware as well as in terms of software, the connectivity became really good. And on the one hand, the devices that generate data, for example, the webcam, the mic, which is generating this data right now, which we are talking, okay, became very, very highly available. The smartphones, the laptops, the computers, they became cheaper, faster, and smaller. And on the other hand, the connectivity became really good, which means the connectivity multiplies the data, as in the way right now I'm generating the data, and there are, say, 50 people in this session. There are 50 people in the session, and the data is getting multiplied 50 times. If had there been 1,000 users in this session, the data could have multiplied 1,000 times, right? So the connectivity multiplies things, while multiplies data, while uh, these devices generate the data, and that's what caused the explosion of the data storage. Okay. Now, why is a big data problem? Before talking about this, let's talk about what are the pillars of computing when we think about who does the computing. Okay, so the whole computing starts with CPU, who reads its instructions from memory. And when I say memory or RAM, I mean to say registers, cache, as well as the RAM. Okay, so CPU reads its instructions and execute them one by one. Okay, executing instructions means taking a call whether to read this data or to read that data. And once done, then what needs to be done. So that is the role of processor. Second is the memory. If you need to do a lot of computing, you need a bigger memory. Okay, so and the first thing that becomes the bottleneck when you try to do computing is the RAM. It's not the CPU. CPU is rarely the bottleneck. It is the RAM that becomes the bottleneck. Okay. And once you are not able to fit your data into RAM, then you spill it over onto the disk. Okay. So the bigger the disk you have, the more data you can store on the same computer. And in case your data cannot fit on a local disk, you put it on other computers, and then you start accessing that data using a network. And that's when we say that the faster the network, the faster you can compute. And hence, all these four components play a very, very big role when we think about computing. Okay, CPU, RAM, disk, and network. These are the four things that need to be the that are the basic building blocks for the computing. And when we deal with big data, at least one of these things will become the bottleneck, to an extent that we realize that we need to have one more computer to do your stuff, do your work, do your computing. You need one more computer. All right. So at least one of these components are going to become the bottleneck when we are going to handle big data. All right. Now, before I move forward, let me take few use cases of the big data. All right. I'm getting a chat. All right. Now let's talk about few use cases. The first one is the recommendation engine. Okay, recommendation engine is probably the most widely used and most widely utilized case of big data. And a recommendation is based on the user's behavior, based on your past history. A software is recommending you something. We have been doing recommendations since ages. We have been doing recommendations since our school days, and we have been saying that, hey, if you like that music, you might like this music. So that is recommendation. And we have been doing it for quite some time. And it can come in various forms, such as customers who bought this also bought that. Wear this cloth with these things, based on churning a lot of data. So Amazon makes a lot of sales due to providing a great set of recommendation. On the similar lines, you have movie recommendation websites such as IMDb and Netflix. There you fill in your past history of movies, and then it gives you the recommendation. So why a big data makes a use case of recommendation is, the bigger the data you have, the better you will get the recommendation. If you have only 5 people, or imagine this, so if you have 100 people liking some movies, the amount of information about the users would be far far less as compared to if you have 1 million people liking the various kinds of movies. So there you can group people together saying these two users are very similar to each other, therefore let's cross recommend their movies. So if I and Karthik, for example, if I and Karthik have watched 30 movies each, and both of us have 28 common movies, so we are very similar person. And finding such similar person is easier if you have humongous data. Okay, and that way my movies can be recommended to Karthik, and Karthik's two extra movies could be recommended to me. The more the people we have, the better recommendation we will get. And therefore it makes sense to have a very very humongous data in terabytes to get a great set of recommendations. Okay, and hence recommendation system is. Prithvi's question is guide how. Hmm, I did not get the question. Could you just form a sentence and then maybe I can answer? Okay. Sai's question is, where do these recommendations get stored in our system, and how do other sites access this stored recommendation? Okay. So it is up to you, how do you want to make them accessible to other websites? And these and the way you and so the way it is done, the way at least I was doing it in Mobi, that every night I will run my job, which will go through the history of all the users and figure out which users are similar and start giving them recommendation from each other. There are many algorithms which have been used to give the recommendation. So, but in this case, I was basically using a simple Apache method. Okay. Uh, all right. So Right. So most of these recommendation algorithms they run in the background. I'm trying to answer Sa- Saksham's question that these algorithms keep on running in real time. Most of these don't. So specifically with respect to the recommendation system, all these recommendations are mostly pre-computed. There are few algorithms that run in real time, but that's not generally required. Okay, the way it is done is you generally prepare a list of user ID, product ID, and how much they have rated, and then pass it through Mahout kind of a solution, and that will give you user ID, product ID, and how much the user will like this movie. Okay, a prediction of the likeliness. Okay, so Apache Mahout is basically a library of these kind of functions, such as recommendation and such as the other categorization classification. It's a machine learning library, and Mahout basically uses multiple kind of algorithms. One is a very simple one, as I told you. Say I and Karthik have similar movies, so it will start recommending to each other. Okay, so that's what Apache Mahout does exactly. Okay, so Karthik's question is that in case of Netflix, if the recommendations are made for a list or a category of users, what scale and how long does computing this kind of data take? Okay, so the data computation takes maybe few hours or maybe more. Okay, and I don't have exact numbers, but what I've understood from them is they did not implement a newer algorithm. So Netflix conducted a contest where people from across the world came, and there were few researchers from AT&T. So we have person from AT&T actually in the session. So a few people from AT&T won the prize to build a best recommendation engine, but their recommendation engine was not used because it was taking little more memory and more time to do the computation, and which was not practical for them. So the thing is that the recommendation itself takes a humongous amount of time to compute on large scale of users. Okay. For me, it used to take close to, at InMobi when I was doing a churning of 200 terabyte data, it used to take around 2 to 3 hours time on a cluster of around 800 nodes. Okay. So Shashi's question is, are the algorithms run on the clone of production database or on the production DB itself? If on the production DB itself, won't it affect the site application performance while the jobs run in the background? I'm so sorry. Okay. Yeah. Sashi's question, let me answer to Sashi's question. Are these run on production systems? No. Generally, you have a different cluster. There is one cluster serving to your end users. Those are real-time systems. Then there is a separate cluster that is designed to run your backend jobs. Okay. And both of these are generally separate. There is a pipeline set such as that whatever changes happen in production data, those changes keep on getting pushed onto your batch processing systems. Okay. So I hope that answers your question. Generally, though, these are two different systems, two different systems altogether. Okay. The servers which you use to serve the end customers generally have humongous amount of RAM, while the systems which you do for churning, they have a little trimmed down configuration. Okay, it's not like your production web server. These are normal servers. Okay. Chandra's question is how complex the algorithms are. So the algorithms complexity vary from one algorithm to another. One algorithm, say Tanimoto coefficient, is fairly simple. It basically says the intersection of my movies and your movies divided by the union of my movies and your movies is how much we are similar to each other, and then based on this it tries to figure out how many users are similar to each other, and then it gives the recommendation. So although some of the algorithms are fairly simple, but the algorithm like the one which won the prize at Netflix was actually pretty complex. All right. Now, Shashidar's question is, does the data get destroyed, deleted after a user session ends, or does it get saved in the database forever? So generally, this data is saved forever until the next recommendation is generated. Okay, so what we do is we build a recommend set of recommendation for all the users, and when the user comes in, we display the data, and then we still maintain it. Okay, because user might come again, and in the evening or afternoon or whatever time, and later on when we run the whole recommendation again, we regenerate the data. So Tharak's question is, how is huge amount of RAM allocated? Is it the sharing of the RAM from network systems? So generally, the huge amount of course the RAM is sort of shared. There are ways to do it, and the RAM which is allocated is in in the form of maybe 100 GB RAM to one of the servers, and so on. Right. So when you are running a cluster, a website which requires a lot of users to be supported, though the memory actually grows up, it shoots up to maybe 100 GB storage, 100 GB RAM, and after that you basically put it on the load balancing, which means some of the users are going to one server, some other users are going to second one, and so on. Okay, that way we can handle it. Sashidar's question is, but if the user clears the cache in the web page? No, no, no. So we have the user's behavior. User logs in. We know who is our user, and we are giving him the recommendation we have pre-computed for him. Okay. So this cache or anything is the recommendation is not stored on the client side. The user logs in. We give him the recommendation. Okay, and the other kind of recommendation which are independent of the user, where we don't know who is our user, say people who like this also like that. Okay, so this kind of recommendation anyway is person independent, is stored separately, so it has nothing to do with the user's cache. Okay, Jenny's question is the recommendation system static, where it maps recommendation to each user, or does it build the recommendation on the fly? So the first one is the answer. So we build the recommendation, mostly we build it before we serve it to the user. Okay. So Sashidhar, was I able to answer your question, and Chinni? Now Tarak's question is recommendation just a link pointer, or it's a separate set of data? So generally it's as I showed you in this diagram here, user ID, although it looks like Kumar and Giri, but these are generally IDs. Okay, these are generally IDs which which are presented using the actual data. Okay, here these are both long, or maybe big 64-bit IDs. Okay, so that you can, you know, and also have a look at our blog. I have mentioned a full recommendation case study over there. All right, so you can say it's a pointer to the data. Okay, is it possible to mix different OS based nodes in one cluster? Probably you're talking about Hadoop. So theoretically, yes, but practically people haven't tried it. Okay. At least I'm not aware. But theoretically, yes, it is definitely possible. That is Morug's question. All right. Okay. So yeah, I actually skipped by mistake the sentiment analysis. The after recommendation, the second most popular use case is sentiment analysis. Sentiment analysis says that on the social graph, do people like you or not? For example, I'm conducting this session. I want to figure out how did my session go. Say I have a 10,000 users who are attending my session. So I want to understand, are people talking about no big data or not? How does the sentiment goes up or down as we do these kind of sessions? Now, the best way to figure that out is using the social network, because that's the data which is available to everyone. And the way it is done is every message is, we try to figure out whether a message is negative or positive. Okay, and there are multiple ways and multiple algorithms to do the analysis of a sentence to compute whether a sentence is positive or negative. So basically, we gather all these sentences, all this data about our product from across the globe. Then we run through a sentiment analysis for each sentence and then figure out whether people are talking positive about us or negative about us. And in this graph, you can see that there are two colored graph. One is positive, other is negative. Okay. Okay, so the red one is negative and blue one is positive. The more people talk about, more people talk positive about you, the blue one goes up, and if people talk negative about you, the red one goes up. So, so that's the significance of the graph. Okay, how do you distinguish the positive from negative feedback? By a flag the like button on Facebook? No. So sentiment analysis is done in multiple ways. One is the direct ones, such as the like buttons, or such as the shares, how many people shared or reshared your status message. Second is figuring out the meaning of a sentence. So if people are tweeting about us, we will try to understand each sentence. Okay, and that is one thing which is fairly complex. Okay, but there are simplified algorithms. So the one exercise which we will be doing as part of the course is doing a sentiment analysis on a very simple system, in which we will basically count how many negative words are there in a sentence and how many positive words are there in the sentence. And in case, and we will give negative words as 1 and positive words as 2. And when we sum up these numbers, the polarity of each word, then in case the output is odd, which means there are which means the sentence is negative, meaning because we have given 1 to a negative word and 2 to a positive word. So if a person is using one negative word and one positive word, that means the sentence is negative. If one person is using two negative words, which means sentence is positive. In case you person is using two positive words, sentence is positive. So when you sum up these polarities, if the output comes as odd, that means it's a negative sentence. If it comes as even, then it's a positive sentence. So that's a most simple way of doing a sentiment analysis. Although it's not correct, because there are many ways to form sentences, such that even if there are two odds, the sentence could be, even if there are two negative words in a sentence, and still it could be negative instead of being positive. All right. So, all right. So Prithvi's question is, how does the computer figure out the meaning of syntax sentence? Yes. Is it done through through NLP? So yeah, Karthik has answered Prithvi's question. So generally, the one which I have told you is a simple static way of doing things. Count negative words, positive words, sum them up. If the output is uh, odd, then it's negative. Output is even, it's positive, right? But there are very sophisticated techniques such as natural language processing. There are really good libraries as of today which you give a sentence and it tells you whether the sentence is negative or positive. All right. So that is about sentiment analysis. Both these case studies we will take up in our sessions. So sentiment analysis will be your project, or if you have come up with something better, come up with something better. I'll totally support you in that project. All right. And so Karthik's question is that can NLP handle sarcasm? Very difficult question to answer. Probably most of the researchers are trying to figure that out. So it does to some extent, but still it's in a very it's not really great at it. So, huh, uh, Murug's question is that how much percentage these type of systems will be perfect, especially when analyzing the textual comments. So his question is that the way we have done the computing, where we counted these words, negative, positive, try to sum them up, is this accurate? The answer is these are not accurate, right? But since we are going to do it on a larger set of data, so the number of data points will actually make you overlook the exceptions, the kind of, say, sarcasm, for example. The sarcasm cases will be few as compared to the bigger data, right? So just by virtue of the bigger data, most of the eccentricities of sentences will be automatically outnumbered. All right. And hence results are fairly accurate if your data is good enough. Chinese question is, isn't big data processing an extension of information extraction, information retrieval on you? So this case which I told you is an example of information retrieval, agreed, and information extractor, agreed. But that's not only the only use case of the big data. The whole story starts from storage. How do you store the data? And after that, how do you do other kinds of computing on data? All right. Prithvi's question is probably natural language process is working on that. Yeah, that is correct. Jenny, we used to use I/IR technique before on normal data, and now the same algorithms are extended onto big data. That is correct, Jenny. So, say for example, let's take a simple case of computing average. Computing average is a very simple problem when it comes to a small data on a single computer. But if you have to do the same thing on top of say few petabytes of data, then it's actually a difficult game. Even counting words is a difficult game when it comes to a huge data. All right. So most of the algorithms which we did, say for example, matrix multiplication. If you go through my blog, you will see a case of matrix multiplication where I have tried to do the matrix multiplication using multiple computers. So sometimes when you have to do a lot of graph analysis, you have to multiply one big matrix with another matrix. Imagine 1 million by 1 million rows, and you have to multiply with a similar matrix. Now, you cannot do this using one computer. I mean, the RAM will overflow anyway. There are multiple reasons you will not be able to do it. We'll talk about these details later. Okay. So therefore, even a simple problem of multiplication of matrix cannot be handled on a single computer when the data is big. Okay. And therefore all of these algorithms are being ported to systems like Hadoop and Spark. All right. The other use cases of big data is government. They do it for fraud detection. Like in case of India, they are using the ID, the identification, people identification system on top of Hadoop. And then there is cybersecurity welfare and justice. And healthcare is one interesting area in which big data is being used at a very, very grand scale, because all the information in case of a healthcare is humongous, as well as the variety is humongous. So it's actually being used quite extensively in case of in case of government as well as healthcare. Then there are few use cases such as telecommunications, where they try to prevent user leaving them by understanding why did the previous users left. Okay, who did they call, what happened, how many calls they got dropped, and all of that analysis leads them to a reasoning that why do people leave, why do customers leave them. Okay, similarly they do a lot of network performance optimization using big data, and calling data record analysis is also done using the big data analysis, because the calling data itself is a very humongous data. Then analyzing the network failure. Okay, analyzing the network to understand the failure. So these are fairly good example, and this is these kind of use cases are generally valid only when you have huge data. If you try to predict something on a small data, say few thousand records, it wouldn't get you any sensible data. Okay, so imagine this. Let's say there are two hospitals in a city. Okay, one hospital says the birth rate of girl is twice as much as birth rate of boys, and the other says that birth rate of girl and boys is almost same. So what is the conclusion will you draw? Anybody? There is a hospital in the city which says that birth rate of girls is two times the birth rate of boys, and there is another hospital which says they both are almost similar. So which one will you, what is the conclusion do you draw from this? Anyone? So there is a hospital. Okay, hospital, let me follow what Tarak was saying. So we have hospital A. It says the number of girl, girl child equals to 2 into boy. Okay. And hospital B says both are almost same. What is the conclusion do you draw? Chini says the average birth rate is 1.5. We can't say for sure. That is Prithvi. Birth rate of girl child is more than 2. Okay. Birth rate of two hospital is almost like 1.5 is okay. Yes. So Karthik says that both hospitals are handling different sections of data, and we need to take in that is good. The size of the data is not enough to conclude anything for sure. Right. Right. So the thing you can conclude from this is hospital BA has very less data. This is the conclusion you can draw. Okay. They just started last week and they have like 30 patients right now, the 30 total birth. And it's just so happened that because it's a too small data to generalize anything, right? Therefore, the bigger the data, the better the results you will get. Otherwise, you will get always these kind of skewed numbers. Okay, so that's the point I'm trying to make. So whenever you do an analysis, the bigger the data you have, the better results you will have. So hospital A, who is claiming that there are twice girl child as many as boy, while hospital B is saying they're almost same. We all know that they're almost same. Okay, so the only reason I could deduce from this is hospital A does not have good enough data. Make sense? Right, so so that is the reason why bigger data becomes sensible more and more. Even sentiment analysis, if you start doing sentiment analysis and you have got 30 messages in total to analyze, it's not good enough. It doesn't make any sense. Yeah. Tarek's question is might be the other way around. Hospital might have the less data. So we all know that naturally the probability of a girl child and boy child is almost same. Okay. We have another source of information which says that the probabilities of girl child is similar to boy child. Therefore, therefore, based on our knowledge, we can say that the hospital A was wrong. All right. Makes sense to you? Now, moving on. Okay. So this diagram essentially shows you who is using how many uh, instances of big data platforms such as Hadoop. All right. So moving on. I hope I have answered everybody's question. These are few common myths about big data. One is it always means data above or in range of terabyte. So of course no. If you remember my example of variety where it was only half terabyte data, right? And still it that kind of data actually becomes a candidate for big data analysis because of the variety and the complex structure and our requirement. So big data does not necessarily always means data in terabytes. Okay, is always about social media and does not apply to me. Okay, so big data is not about social media. It's about more about how much data do you accumulate. It will replace enterprise data warehousing. The answer is no, it will not. Reason being, EDW is serves its own purpose. Okay. All right. So EDW is great for smaller but very, very consistent data. If you require a great amount of consistency as well as you require transactions onto your data, probably a relational system will be far, far better than any of the big data solutions. All right. So they will coexist based on what problem do you try to solve. It is just a buzzword, no practical application. This is definitely a myth. Fifth is that because I've been using big data solutions for quite some time, and I can for sure assure you that it's not just a myth or bubble or just a artificially created wave. It is not. There are use cases, people are utilizing it. I've seen it at places like in Mobi and other places. Everybody is using it. Fifth is a new concept. The answer is no, it's not a new concept. All right. It has been there since 2002. As I was telling you about Medisha time, we were handling terabytes, petabytes data at that time. It will be future. Of course, no. It is the present. Okay. Is expensive, so almost all the big data technologies is open source and freely available under Apache license, and Apache license is probably the best one out of all the licenses. So it is actually the cheapest amongst all other solutions. There is nobody's proprietary, everybody, the whole software is free. It's just that few implementers are there. Eighth is it is only for data scientists. Or is magic? No. Data scientists build algorithms. They provide those algorithms in the form of Mahat, and so it's no longer a magic. We have enough hardware and don't need it more. So big data is not about hardware. It's not about acquiring new hardware. It's about utilizing your existing hardware. Most of the big data solutions have been designed to run on commoditized machines. Commoditized as in a normal computer which people buy. Okay. So so it's not definitely about hardware. You don't have to generally, if you have already some amount of hardware, you can utilize that. We will build it when we need it. This is probably the most fatal myth out of all. So the reason is if you do not build a storage mechanism with which you can tell all your developers and everybody to gather the user behavior as much as possible instead of deleting the user behavior, instead of deleting the Apache logs, if you store it, it will be great. You will be able to do the insights tomorrow, not the other way around. Okay, because the day you realize, oh, I could give the recommendations to my user but I don't have data. And why you don't have data? Because you did not plan, because you said that we will build it when we need it, right? Now 11th is big data is about Hadoop. No, Hadoop is just one solution and big data is Hadoop is just one solution. There are multiple solutions of big data. All right. Now, Chanda's question is, then should we change the first slide? Which one? Okay, so there is a disconnect. Right. So it says that here we are talking about a terabyte. Not necessarily. When it even if when it's few hundred GB, the your problem could still be the big data problem. All right. Naveen is saying sorry, net connect issues, late joining. Okay. Alright. Okay. Right. So yes. So probably this is what you meant to say, that we talked about the big volume of the data, petabyte of data, and now we are saying always mean it's a myth. Okay. So it's actually the same thing. What I was trying to say is, if you have even if you have few hundred GB data, as I was telling you about the third point, which was variety, as well as in case of our second example, velocity, where there are lot of requests coming to the server, such as a stat counter, a website stat counter, the actual storage is actually very small. In a stat counter, the website hit counter is actually updating a single digit. It's a single number, not digit. It's a single number, right? The storage is almost negligible. But if there are a million users on your website in couple of hours, the software required to handle that kind of hits need to be really distributed. Okay. All right. So should we move on? This is the short summary of jobs, and as a thumb rule, you guys should actually go and little bit do an analysis on the job sites, and you will realize that there are a lot of people looking out for into big data. And even recently in the 2015 January report, Forbes as well as Gartner, they both are still saying that big data is something that people need to move into it. Okay. And that is one reason why there are so many openings into this job market. All right. So have a look at this, do your own analysis, and understand that there is a requirement. So technology is very real, because I have been using these kind of things for quite some time, and I'm quite happy with the kind of tools which have come out. Okay. Now, okay. So the other big data solutions, somebody was asking, are, say, Hadoop is the one which is most complete solution out of it. It has a file system, it has everything. And then we have Spark. Spark is only for the computing, not for the storage. We have Cassandra, which is good for storing the data in relational format. Relational as in a database format. Similarly, we have MongoDB. If your data is structured, MongoDB is good enough. And then there is Google Compute Engine. So out of all these solutions, the best, cheapest, and most complete is Hadoop. All right, right. So Prithvi's question is, why is the Hadoop most heard of or most popular? Okay. So as I told you that it is most complete, that is why it's most popular. Okay. So Naveen's question is, I guess Mongo is not big data. It is document based, isn't it? Okay, that's a good point. So MongoDB can handle a lot of data. Reason being, MongoDB is designed with the distributed architecture in mind. Okay, so MongoDB runs multiple instances parallel, and the data is sliced into multiple sections and stored on multiple machines. Okay, so, and MongoDB, because by virtue of its architecture, which is distributed, it can handle any amount of data. Okay. So therefore, it's actually a big data solution. What are the advantages of Hadoop over Cassandra MongoDB? So Hadoop is not only the database. These Cassandra and MongoDB are just the data storage. Hadoop is far more. a complete solution. All right. Now we'll talk about it. Now this is my. Let's take a quick break. Okay. Let's take a break for 10 minutes and come back at. Okay. So so let's take a break of 10 minutes and then come back after 10 minutes. All right. All right, so I'm back. Should we start now? Sorry for. All right. So let's start now. Okay. So Chandra's question is that what is, can you explain a little bit about NoSQL? So the database, when it becomes distributed, as in a same database running on using multiple computers, it is generally termed as NoSQL. Okay. We'll talk about it in session number 6 in more details. Nothing to worry on that. All right. All right. So Rohit's question is by complete solution. What does it mean? What does it that makes the Hadoop complete? You'll see in a minute. Okay. So Hadoop is one framework to handle big data, and in Hadoop's terms, the way it handles big data is it's for reliable, scalable, distributed computing. Okay. It is for distributed computing, and it has to be reliable and it has to be scalable. So it started with two guys, Dog Cutting and Mike Caffarella, trying to build a search engine called Notch. And at the same time, Google came up with a Google File System, Google MapReduce, and Google Big Table papers. They published those papers. And based on those papers, Dog Cutting and Mike Caffarella, they implemented all three of them and made something called Hadoop. Okay, because in that search engine they realize that when they have to handle big data, they have to have a framework, they have to have a solution which can handle that amount of data, and that was not available at that point of time. So they actually implemented those three papers by Google, and that became Hadoop. And after that, Hadoop has become an umbrella term because they have been adopting various products, and under a single umbrella they have close to 12 products under the umbrella. All right. So now Hadoop is more like a umbrella term. The most important milestone in case of Hadoop is that it was Apache open source, which means that if you want to use it even for professional use, nobody can come after you, nobody will have any questions. It will be absolutely perfect and okay. Even if you want, you don't have to pay anybody to start using Hadoop. All right, it's well supported across the globe, and it is since it is to run on multiple kind of computers. It has to support a language which can run on all places, and that's why it was written in Java, because Java probably runs on the most number of devices in the world. All right. Okay. Now that is Hadoop, and what is it that consists of Hadoop? These are the various components that make a Hadoop what it is. All right. So let's talk about something Hadoop distributed file system. That is the most important component of the Hadoop ecosystem because that's the base of all. Like in your computer, there is a hard disk which stores everything. Similarly, and hard disk has the file system. Similarly, the basic component is probably HDFS. On top of that HDFS is are the other components built. So, why exactly we require a new file system? Before jumping into that, let's discuss a simple problem. Then that simple problem is you have got 100 terabyte of data, okay, and you have to store it. What will you do and how will you do it? So, Imagine that you are trying to build a video store where all your colleagues can store the videos and they can watch any video at any moment of time, and your estimated storage is of the video storage is around 100 terabyte data. Okay, or you can think of that in your organization decided to keep a server for movie storing all the movies of the world, and then you want to watch all of those. Okay, so how would you build such kind of a system? Okay, and you are the architect, you are supposed to build such kind of solution. What is it that you will do? Anybody? Remove duplicates. Agreed. So after removing duplicates, we realize that it's still 100 terabyte. That was Chandra's point. Yes. So let's say that after removing the duplicates, we realize that it's still 100 terabyte. And after removing duplicates and after zipping the data, compressing the data, it's still 100 terabyte. Now what will you do? Now Chinny says would divide the data storage across the computers. Great, excellent. Could you elaborate? Prithvi says it has to be on multiple computers. Good. Now Murug says that we'll keep metadata in RDBMS and store the media files on some file systems. Very good, excellent. Go ahead. And Chini says that divide 1 terabyte each and divide to 100 computers. Great, great. Sashidhar says I would use cloud of all right. So see, here you are the engineer. You have to build that kind of thing. Okay. Okay. So the discussion is that how would you build it rather than rent it? Yes. Yes. All right. So Sridhar says that he'll store the metadata on one database and he'll store files on a distributed file system, and to save data so it's easy to access data from the any system. Good, good. Venkatesh says multiple storage with expandable volumes. Good. Divide the data and store the metadata reference on where the each chunk of the data is. Divide the data. I'm repeating Chinny's question, Chinny's answer. Uh, Divide the data and then store the metadata reference on where the each chunk of the data is. Okay. Yes, yes. Okay. That is good. That is good. That's in conjunction with Sashidhar. So what he's saying that divide the data and store the metadata reference, basically the pointer to the places where this data is at one something called metadata. Okay. We will expand the hard drives in a server. That is Lakshmi. So could you elaborate? I would love to understand it. We will expand the hard drive in the server. Mhm. Okay. Shashi says that have multiple systems with service running on each system acting as a access point on each. Good, good. Widely used movies keep it on main system. This is Chandra's answer. Let me repeat it. Widely used movies keep it on main system. Okay, and remaining on separate system. Okay, that is also a good architecture. Now, yeah, Prithvi says that you might not have 100 computers. Okay, Puneet says store it in a distribution index and index it for easy fetch. Good, that was Puneet. Prithvi says, how about we reach a point where metadata itself is so big that it needs to be stored in DFS. Yes, so that's the next step. We'll talk about it. We can go with compressed format such as Sybase IQ DB2 and different machines forming cluster. Good, good. That was Naveen's point, that compress it, as Chandra was saying, that compress it and then distribute it. Good. Use a combination of multiple systems and a server. Good, good, great set of answers. So most of you have actually gone a step ahead. So I'll just stay a little, one step back so that I can justify reasoning behind Hadoop. All right. So Let's imagine this, that you bought 100 terabyte hard disks, and you bought few computers in which you put these hard disks, and then you connected all these computers together such that these hard drives are available to you as a network share. Okay, and so to make it further simpler, we went ahead and on one of the computers, what we said is we created a folder called main folder, and under that we what you say mapped each of these hard drives to a folder. So our main folder contains 100 subfolders, each of these subfolders representing a hard drive. Now, when we are storing movies, we devised a scheme that some of the movies starting with A will go to drive 1, starting with B go to drive 2, and so on. Do you think a problem with this approach? Do you think there is something wrong with this approach? Yes? So what we did was we bought few computers, we bought 100 hard disks, put the 100 hard disks into the computers, and then connected these computers into a network. Then we did a mapping of the hard drives from all these computers across onto one system. And this. Now, first and foremost, Morgan says that if one disks fail, then we lose the data. Very good point. Very good point. So to defend against it, we build a plan called RAID 0, in which drive 1 is having a mirror image on the same computer. Okay? So drive 2 is having a mirror image on the same computer and so on. So even if one drive now, so does that stop the data loss? Venkatesh says, what if the main system is down? Very right. Yes, accumulation of data in one disk instead of equal sharing. Good, good. That was Puneet. Puneet says that the data will not be distributed across the cluster. Okay. That in one machine will get lot of data, another machine will be fairly empty. Right. Santosh says that although in response to my argument that we'll keep a backup on each machine in the form of RAID 0, RAID 0 is a way to mirror the data on the disk. Okay, so we mirrored the data in drive 1 on the same computer, but it is costly. That's what Santosh says. So, but that is okay. We are ready to sacrifice that much of storage. For 100 terabyte, if we have to buy 200 terabyte of storage, that is okay. All right, Santosh. Movie with A to C keeps on increasing, and with Z is static. Yes, yes. So again, Haskam says that all the movies from A to C will have more and more movies coming in every day, while the one which is having Jet is having less movies and that folder will be empty. Anybody else? Do you see any other problems with this approach? Yes. So Karthik says use NAS for static storage and cache-like system for quick access and passing. Anybody else? Yeah, a separate cluster for cache. Okay, yeah. And anybody else? Any other suggestions? Okay. Any other problems do you see with this? There are actually multiple problems. Use IO on main folder and become the bottleneck. Very good. What is NAS or SAN? Thank you, Prithvi, for asking that. NAS is network attached storage, or SAN is storage area network. The design of both is similar to the one which we have given. All right. Any other problems do you foresee? Now, here are the challenges what you will face when you build such kind of thing. One was failover and backup. So we mirrored the disk, but what if the network cable disconnects? What if the computer shuts down for operating system issues? What if computers becomes heated up and then that particular computer burns? So mirroring a disk does prevent us from losing data due to hard disk failure, but it does not prevent us from losing data due to network issues or a particular whole computer burns, then you cannot save it. Okay, that is why failover is very essential. Failover, as in when something fails, who is taking its place? The system which we have designed, although it might have backup, but it doesn't have a failover. How would you distribute data uniformly? This is every one of you have told me this, because the movies from A will keep on coming every now and then, but movies from Q and Z will be very few. Okay. Third is this the best use of resources? Why? Because we already might be having a lot of hard disk lying around in the organization, some 100 GB, some 80 GB, some 30 GB, some 50 GB. Can't we utilize those? And the next point, which is probably the most important one, is what about increasing availability? What does it mean? It means that a movie got released yesterday and everybody wants to watch it. Now, on whichever computer we store this movie, that computer is going to go down, right? And therefore, because of the overload, because everybody wants to watch that movie, and that computer has got limited resources, their hard disk has only one header, one reader which reads the data physically, right? So that hard disk has got limitations. So it can't serve to many customers at the same time, right? What about scaling out? Today we have 100 terabyte demand. Tomorrow it might grow to 120 terabyte. And day after tomorrow we might need that, hey, can we move to 200 computers? So that is scaling out. Okay. Now what's the difference between scaling out and scaling up? So if you imagine that you had a cart and you had a bull. Now, instead of few tons, you need to increase the capacity of carrying more and more weight. If you discard your bull and buy an elephant to pull the cart, that is scaling up. If you add one more bull into your cart, that is scaling out. Okay, that is scaling out. So, in the same analogy, in when it comes to the computers, if we increase the CPU, increase the RAM of the same computer, then we say that we are trying to scale up. But when we try to add one more computer to solve your problem, that is called scaling out. So, scaling out is a challenge in this game, what I've suggested. So Karthik's point is, what about multiple NAS systems to share the load? That is nice. Yes, that is good. Now, how do we solve these challenges which we have talked here? The answer in simple words is Hadoop distributed file system. All right. So to handle that kind of uh, you know data, you definitely require a more sophisticated distributed architecture than the one which we built. Although this is also distributed architecture, but it's not sophisticated enough because it has these challenges, and therefore we require a Hadoop distributed file system, right? Now, what exactly is HDFS? I'll try to keep it as simple as possible. All right. If you have any questions, any doubts, so should we start with what is HDFS? Are you guys with me? All right. Great. Great. All right. Perfect. Perfect. So we have everybody. Good. Now, what exactly is HDFS? How is it designed to handle such amount of storage? So HDFS is Hadoop distributed file system that runs on multiple computers to provide you enormous amount of storage, and it is absolutely solving all these problems which we discussed just now. Okay. Now the way it is designed, it has a single system called admin node, which is singular, meaning there is only one admin node in a cluster. And there are other nodes called data nodes. There are multiple nodes. Okay. So it's a typical master slave kind of design on the surface. So while the name node, admin node, is sort of like an index, okay, it keeps the index of what is where, while the data node store the actual content of the file. So if you have a movie which has got, say, Shawshank Redemption.avi in the folder called movies, so this is metadata, like the name of the movie is Shawshank Redemption, file name is this, size is this much, that is metadata that goes into admin node, while the actual content of the file goes to data nodes. Okay, while the actual content of the file goes to the data node, an admin node is sort of keeping a book, noting down what is where, which data node contain the which file, and so on. Okay, and this admin node stores all of this metadata into the memory. Okay, so Tarak's question is, will the data node also have the metadata like name of the movie? No. Okay. Say you want to store Shawshank Redemption.avi. So admin node will have this information that there is a movie called admin node and it is stored on this data node. And this data node will only have some, will be storing data in binary on the local file system. Okay, on the native file, using native file systems such as FAT32, NTFS and all, and will be only knowing about this data what is inside the file, not the file name or anything. Okay, so Murug's question is, what if admin node fails? So admin node has a backup, okay, which is always active, which is exactly a mirror of admin node. Okay, we'll talk about it again. All right. So the data is stored in data nodes. The index, as you were telling all of you, that there is something called we'll keep a ledger where we keep an information about which file is where and so on. Now, let's go to next step. In the data nodes, it's not the full file that is stored, but the file is sliced into blocks of 128 MB. Earlier it was 64 MB. Now it has become 128 MB. And so you slice your files into blocks and then store into data nodes. This makes it possible to store very big file into small hard disks. Okay, it utilizes the space. Second, it is easier to move. Uh, it is easier to move around your file, and it also helps you distribute the load into the machine onto the machines. Now imagine this. User A came to watch a movie. First 10 minutes were served by data node 1, next 10 minutes were served by data node 2, and so on. This way, while watching a movie, all the computers are utilized. Okay, so which means if I and you are coming at a gap of 10 minutes to watch a very popular movie, we will not be overloading one system. Our we will be this will distribute the load onto the cluster, right? So do we not face IO bottleneck with the data nodes? Not really. Not really. I'll tell you why. Because this exactly solves the IO bottlenecks. So these are the reason, as you can see, Naveen, these are the reason why do we want to split the files into blocks. Exactly. So Siddharth says, wouldn't that mean that metadata on the admin node has to additionally specify where each chunk is? Of course. So admin node, that's what we say, that admin node knows that what are the various folders, what are the various movies, and how many parts each movie is having, and where are they located. So this information is stored on admin node, maintained over there. The full movie, okay, Santoshi's further question is, the full movie does not store on one data node. Will it be distributed too? Yes, it will be distributed. Tharak says that can there be a multiple persons accessing the same data node? Then in that case, there not be load on the same data node. So the there will be no load on the data node, but in case of a huge traffic, the data load is automatically getting distributed. So even if there is a movie which got released yesterday and there are a lot of people who want to watch it, the load is getting distributed across the cluster, not only those few computers. There will be load, yes. Sashi says if multiple people want to watch the same movies, won't the same data nodes get overloaded? So generally the way it works is system keeps on getting distributed and you end up having your file distributed across the cluster, which means that which means that the load is going to get distributed across the cluster. Okay. So Muruk's question is, will there be any difference in storing 32-bit and 64-bit nodes on the same for the same 128 MB block? It does not impact the architecture of your CPU, does not impact the block size or the way the block is formatted. All right. Isn't latency an issue? That is Karthik's question. The answer, so latency, you might be suspecting that while I'm watching movie, I finished my first 10 minutes. Now it will start reading from another server and so on. So those issues can be fairly reduced by starting to make connection before you finish the movie at one place. First block, if you finish before finishing reading, playing the first block, you move before moving to a next one. You start doing it early. Okay, so so that way there wouldn't be a latency issue. Other thing is, since these data nodes are location conscious, so you can read the data which is closer to you. Now, Chinese question is, what if admin node goes down? Admin node has got a backup. Admin node keeps on informing its backup that this is the metadata, this is the metadata. Also, each data node keep informing to admin node as well as the backup node that this is the change in metadata, this is the change in metadata, these are the blocks which have been added. So Naveen's question is, I think data is sitting in cache, so RAM reads will be faster. So actual data is not in the cache. The data which is in the cache is indexed. The admin node keeps the data in the RAM, and hence it will be faster. Okay, now before you guys start jumping ahead, oh wow, I've got so many questions. Wow. Let me just finish next slide also. Probably by that time your questions will be answered. Each block in data node has multiple copies. Okay, so let's say one for each block we copy the block to other nodes as well for reliabilities, and this factor is called replication factor. So the factor by default is 3, but you can set it per user basis, per file basis. That this file is important, let's keep its replication as 10, which means there will be 10 copies, and this file is less important, let's just keep 2. So that is called replication factor. All right, so each block is replicated that many times across the data nodes, effectively utilizing 3 times of space, or utilizing replica factor times the space in the network. But each individual disk is cheap, so if your data is important, have the good amount of replication. All right, if data node fails, let's say one data node goes down, with that lot of blocks went down, which means those blocks still would have say 2 copies available in the network. Using those 2 copies, the third block is again regenerated. Basically, one more copy is made to bring down the backup again to 3, right? This way, these data nodes keep on rebalancing each other and hence make sure that nothing is lost. And the automatic movement makes it really great use case for resilience. Okay. Now let me read your questions. Sasidhar says, let's say a movie is distributed into 3 data node. If data node 2 fails, then movie in the data node will it exit? Will the movie go to data node 3 or will it exit out? So you got your answer. Ravi and Shashidhar, you have same questions. What about when the change of node occurs? Okay. So what you do is, if you realize that data node 2 we need to take out from the network, so data node 2 you just shut it down and wait for the replication to finish, and then you add another fresh computer, and let the rebalancing happen. Okay, that's how you change a node. Karthik, was that your question? Prajesh says that how the admin node detects failure of data node and take another mirror node. So admin node keeps getting pings from all the data nodes, as well as it keeps on pinging each other. So they keep on talking all the time. In case a data node goes down, in case a data node goes down, the data on that data, in case a data node goes down, admin fails to receive ping responses from data node, that particular data node, and then it immediately informs other data nodes having the same blocks which were lost just now, and it will inform those data nodes to start copying amongst themselves, or to another computer. Okay. Now, Siddha says, does the network ensure that different user access different chunks of the movie at the same time? The load get distributed only if this is true. Yes, that is correct, Siddharth. So this is admin node makes sure that when the user comes to read the data, it keeps an accounting of how many people are reading the data and so on. And based on it, it redirects the user to that particular node. Okay, so if multiple people are watching the same movie, that will be still try to access the same block across the cluster at the same time, and hence causing the performance issue. No, so if multiple people are watching the same movie, and you know that it's a good movie, you increase its replication factor to 10. All right. Now imagine this: each block is stored on 10 different machine, and admin node is redirecting you to every time a new user is coming. It's redirecting to a fresh node containing the data. Okay. That means that the load is getting distributed across the cluster. So Saksham's question is basically the OS internal memory system has got the similar concept. If you think about any file system, that is how it works. There is something called file. You say the the header, we call it. I'm just missing that name. In that, it's a pointer to various locations in the file system. Here, it's a pointer to the which machine the data is stored. Naveen's question is that if we have multiple read access for the same data. Yeah. Saksham says like stores in multiple blocks. Yes. Can we add more data nodes? If yes, will these data nodes be used for already? Yes, that is correct, Ravi. So as and when you add more data nodes onto the cluster, the blocks start rebalancing. Blocks automatically move to the freshly added computer. Right. If huge volume of people want to watch this movie, then admin node will be hit with the traffic to direct each movie request. Right. Now let me answer that question. Wow, these are so many questions. Okay, let me just finish the next slide and then I'll answer your questions. Okay, so the way we imagine such kind of system is this. Uh, but but before you build a picture, this is not the architecture of HDFS. In typically we imagine that there will be something called like a supervisor. I'll go to him and say, can you give me my file? And that guy will give me my file. Right now, the downside of this architecture is that this name node is the most busy system out of all, right? Because it will read data from each data node and then give it to you, all the blocks. Instead of going with this architecture, what HDFS did was they said that let's have it in this way. We have a driver, client driver, who 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 is basically a client library being used by your user. It comes to the name node saying, hey, give me this file. Name node, instead of reading it by self, it redirects the client to the data node and says that, hey, go and read it by yourself. Don't bother me. As long as you, uh, if you need any information about which file is where, I will help you, but you will have to read it by yourself. I will not read the data and give it to you. That's what name node tells the client. Okay, here are the block numbers, go and read it from there. That way the name node is hardly busy. It tries to free itself as much as it can. All right, so that's a one design. Now, before updating to admin node, what if it crashes? Okay, now that is a good question. Okay, now in the same way, let's look at the typical way we write the data. This is what goes on. There is an HDFS client. It goes HDFS client as in your library which you are going to use. You go to distributed file system, and then you go to name node. Name node says that, okay, fine, you came to write the file. Tell me the name of the file you have, and please go to this data node and write it by yourself. And once you are done with writing, come back and inform me that you are done with writing. Okay, so your client goes to the data node and starts writing the data, and in case it fails to write the data, name node realizes that you started writing to a file but you have not completed. Okay, because data node would not send a confirmation, and after a point of time, name node will disregard your request for creating the data. Okay, Chini, that is correct, right? I'm trying to answer your question. Can data nodes exist in different geographical location? Of course. That is the sole purpose of couple of things, right? And generally one copy of the data is sent really far to avoid, in case one geographical location is burnt down, if then the data is always available in the second geographical location. All right, why is minimum 3 not 2? Is there any specific reason? So that is Tarak's question. Now, it's a very difficult question to answer. Why minimum 3 not 2? Okay, so having 2 is very important as the backup. Okay, having 3 is great. Okay, reason being, the files are sliced into pieces, right? Files are sliced into pieces. Even if one piece goes down, one computer containing one piece goes down, your whole file is wasted. Your whole file is useless, right? Therefore, by increasing the blocks, by slicing the file into blocks, you have increased the probability of losing your data. You've increased the probability of losing your data. Why? Because either of the block fails, your file fails. And chances of the servers, either of the servers out of 100 failing is high. Therefore, by slicing the file into blocks, you've increased the probability of the failure. Therefore, it is recommended to have two backup copies. Sorry, it is recommended to have two backup copies, meaning 3 replication factor. All right, and 1 is totally useless, 2 is good, but 3 is better. So Chandra's question is, to implement Hadoop, how many systems do we need? If you download virtual machine, even one is sufficient. Reason being, data node, name node, and all of these, name node and data node both, are essentially processes running on a particular port. These are network processes running on your machine. You can actually run all of them on the local machine. It's not a problem. You have the same machine, but it does not make sense, any other sense than learning purposes. Okay. All right. So you can have all the data node, name node on the same machine, but it is generally recommended to have at least minimum three. That's correct. So let me read out few more questions. Okay. Ping depends on the network, and if that is the case of failure, then I think admin node will try to sync the data nodes once network issues resolved. Okay. That is correct. You're right. Ping depends on network, and if that is the case of failure, I think node will try to sync the data node across the network issues. Yes, yes. So HDFS keeps on resyncing all these data nodes all the time. Yes. Saksham's point is, inconsistency could be an issue. Let me understand what exactly do you mean by. Okay, so he has given an example below. Say one file has got two copies and having four blocks, and block two of the copy one is lost. Then, no, so let's not look at it this way. So file is sliced first and blocks are copied later. So it's the blocks which have the replica. And these blocks are always on different machines. Okay, let me read out your question to everybody. Now, say one file has got two copies each having four blocks, okay, and block 2 of copy 1 is lost, then we can use 134, right? Yes, of course. This can only be issue if 1 to 3 blocks are implemented using linked list. No, no. 1 to 3 blocks are not really sequential. They are, they are sequential when you're combining, but it's not like a linked list, definitely. Linked list, when you say linked list, meaning one block having information about the next block, right? Only then, in case one block gets lost, other is also on the verge of losing. They are not linked list. Yeah. So I did not get. Say one file has got two copies, each having four blocks, and block two of the copy is lost. Then, so was I able to answer section? No. All right. So now somebody was saying earlier, which I forgot to complete. Somebody was saying that big data solutions were there before. Why is it now? So the difference lies in this slide. Big data solution which we built earlier had these kind of inefficiencies. Those kind of inefficiencies were removed to a very large extent by bringing this kind of architecture in Hadoop. Okay. All right. So okay. So that was the anatomy of file write. Client goes to the name node, says, I'm going to write this file. Name node says, "Okay, go and write on the data node 1 or data node 2 and come back and report to me." And then client does that, and once he's done, that block gets copied across to data node amongst themselves to have their application factor equals 3. And once the data is finished writing, the name node is informed that, hey, I'm done. All right. Now that is file write, and file read is similar. As HDFS client goes to name node, says, hey, I want to read this file. In return, instead of giving the file, name node says, I've got these five data nodes containing the blocks you're looking for. Why don't you go there and read it directly? Don't bother me. The metadata that is contained in the name node is, there is two kind of metadata. Entire metadata is in memory first. Only the and this day metadata is paged onto the disk, so that in case memory is lost, the data is there on the file system. And then there is something called types of metadata, meaning what is it that metadata contains. Metadata contains list of files, list of blocks of each file, and list of data node for each block. Okay, each file has got blocks, each block has got data node, and okay, so file contains block, blocks are located on data nodes, and blocks are replicated across the data nodes. Okay, the other kind of metadata that is stored is access time and replication time, and so on. All right. Now there was one question which I missed, was what is difference between Hadoop and Apache Moth? We'll talk about this in a minute. What if the write fails in between? So when you are trying to write to a data node, if write fails, the whole block is lost. Okay, and say and you are not able to go back to the name node, informing name node also that, hey, my write failed, please don't write anything. In those cases, after some time, name node will expire that the fact that you tried to write some data. Will HDFS client write one block at one time, or for each node? Will HDFS client write one block at one time for each node? Yeah. So kind of yes, but it is, if somebody has implemented parallelly, they can actually start writing parallelly also. But the way default client works, that it writes sequentially. Prajesh asks that. Prajesh says, yeah. So you got the answer, Prajesh, right? All right. So okay. All right. Any questions still here? So this was a very high level overview of our name node, and typically this is how it looks like. I'll show you quickly. So although it looks like that there are admin node, there is data node, this, that, there's a replication, but on this you can see that it's actually like a standard file system. This is the HDFS file system. You can see that it has got a file command line client also, and so on. Okay, so this is our HDFS. This is our HDFS. Now, Saksham's question is, for 100 terabyte, what would be the ideal size of name node metadata? So it all depends how many blocks are there, how many blocks are being replicated, and so on. And what is your block size? Generally is 128 MB, so it'll be few KBs only. Okay. Now we talked about HDFS. Okay, we talked about HDFS. What about other components? Other components, say Flume, it helps you import data from unstructured data. Unstructured may be Apache logs, maybe videos, maybe audio, and so on. Then there is a tool called Scoop. Scoop helps you importing the data from relational databases onto HDFS or other systems. Now, on top of HDFS, there is something called Yarn Compute Engine. The, the quality of Yarn is that if you want to, instead of bringing data to the code, it takes your code to the data. As we talked about, our data is humongous and our data is distributed across the cluster. So instead of gathering all the data together to do some computation, Yarn takes your program to various nodes and get it executed there. That is the role of Yarn. Yarn is part of the Hadoop, and on top of Yarn there are various paradigms such as MapReduce and Spark which are run and on top of Yarn. Parallelly, there is HBase. HBase is basically a very rudimentary database in which we can store millions of columns by billions of rows and so on. Okay, so that is HBase. HBase is a NoSQL database, which means a distributed database. And on top of it, there is something called Hive. Now, for every problem of data churning, you cannot keep writing MapReduce. For every problem, you cannot keep writing in Spark. Instead, you would like to utilize your SQL knowledge, right? To do that, there is a solution called Hive, which internally converts the SQL query to MapReduce, and it works very well. All right. So Hive's role is take your query and then convert it into MapReduce, execute your query onto multiple machines parallelly and get the results. And these multiple machines are same machines as data nodes. Why? Because instead of taking the output from one machine carrying it all together is difficult, meaning bringing data to the computation is impossible when you the deal with big data. Okay, and SQL makes it possible, Hive makes it possible to for you to you keep on writing your queries into SQL, and it keeps on converting that SQL into MapReduce, or you can think of a distributed way. Right now, after Pig, people realize after writing Hive, people realized that Hive was not supposed SQL is not really a great language when it comes to distributed computing. Therefore, they designed a similar language like Pig Latin. It's called Pig Latin, which is very similar to what is SQL. Okay, but it is heavily tuned performance wise. It's far more performant than Hive. Okay. Now, there is a small component part of the Hadoop ecosystem which is called Mahout. Mahout is essentially a library prepared by various data scientists. You can utilize the Mahout library to do lots of magic on top of it. All right. Now, as you can see that you have these so many components. Okay. Some of your part you will be doing in Hive, some of the part you would be doing using Pig Latin, or some of the part would require data importing and so on. To build a complete solution, you need to utilize all these components. Now, question is, how do you run all of these together to achieve some objective? So that's where the workflow engine called Uzi comes into play. The workflow engine comes into play exactly for the same purpose. All right. And you can use all of these using command line, Java or Python. All right. Now, that is about it with respect to the Hadoop ecosystem. So, those who have signed up with us already, please start using Cloud Labs. It is for real life experience. The way I had experienced at Amazon, that we were provided as a developers, we were provided with access to cluster so that we could explore and experiment. In the similar manner, we have provided Cloud Labs, which you can access from anywhere. You can access from home, access from office. Okay. Now, after you have finished today's session, please finish the quiz mentioned in the learning management system. This is for the students who have already signed up with us, and go through the console here. Try to understand what does each one say. This is the console of our Cloud Labs. It shows you what are the services running, how much memory is left, how much memory is busy, and so on. So it shows you the details about each and everything. All right. Now you can connect to us using either to understand what's going on the administration level. You can log into console. The detail about login password is available in the installation instructions in session 1. So go to session 1 in my courses. You can see the detail about installation instructions. Under that you will also find the login password to access the cluster. All right. Now go to admin console just to check what's going on. So admin console will be read only for you. Hue is something interesting. It makes it possible for you to interact with HDFS, and SSH makes it possible to run any command on any server. People from Windows can use PuTTY to connect to these servers. All right. Now those people who are interested in learning Java, they will for everyone we have a complimentary course in Java. If you click on my courses, you will see that course, as well as there is a regular expression session in under the Hadoop's first session, because we realized that regular expression is required, so we give Java as well as regular expression as complimentary. You can have a look, go through that, and those are very much required. Also, you can set up your own virtual machine if you wish to, but make sure that you finish the assignment available in learning management system. Okay. Now, Ravi's question is this infinitely scalable? In theory, maybe, but no, because name node has got the bottleneck, right? So it's only few exabytes it can go to. Good. One question which we missed is Morog's point is, who is responsible for slicing files into blocks? So it is very clear first that it is not name node. Okay, it is the HDFS client. The command line you are going to use to upload data into HDFS is the one which basically does the job. It's the client who does the job. Name node or data node do not do that. Okay, so the guide is available under installation instruction. You can use that, Prithvi. So is there a login password we need to know? Basically, those people who have signed up for our courses, Prithvi, they must have got their login password. If they haven't got, uh, i- if you have signed up, let us know. Okay. So Saksham's point is, this is the first time I have attended. Please let me know where is the first so this is the first session today. We have This is the first session. If you go to my courses, if you log into the server and you say my courses, you will see Hadoop, and under which the session 1 tab will contain installation instruction. But note that this that will be available only you have if you have purchased the course. Okay. To sign up for the course, Murug, you could go to the online and click on enroll now, and you can sign up for the course. All right. And the course one is starting today. The second class is from 22nd February, which is tomorrow. Okay. At the same time, you can either sign up for tomorrow's class or you can sign up from 1st March class. If you have any doubt, just drop us an email at reach us at no big data, and this is our phone number. Okay. If you have any questions, just drop us an email. We will uh, respond to you immediately or give us a call. Okay. So any questions for me in this duration now? Okay. If you have one more thing for installation instructions on virtual machine, those people who want to, you know, install virtual machine, that is probably very quicker one. You can just download a virtual box, download a virtual machine, and then import the virtual machine into virtual box, and you will have whole thing running. We prefer Hortonworks installation over Cloudera because of the efficient systems. Okay. And I would strongly recommend to go with Hortonworks one because it does not store too much of data onto my disk. Right. Prajesh's point is that any corporate level cost. Mm, I mean, the cost is same for everyone. Cost is same for everyone. We keep everything transparent and open with everybody. Okay. And we can have a discussion over phone if you have more questions. All right. So, all right. In case you have further questions, please drop us an email or join us on the forum. Here is, if you go to our website www.nobigdata.com, there you will see something called forum. I or any of our students will respond to your questions. Okay, log in onto the forum. You can sign up. Okay, for being the part of the forum, you don't require to be a student, so you can join us on the forum. All right. Any questions? I hope I have kept you awake till now. Good, good, good. All right, so let me know if you have any doubts at all, and feel free. Those who are, signed up already, please finish the quiz and start working. In quiz, there will be few questions related to the task tracker and the yarn framework. So you can skip it now because that will be covered in the second session. All right. Yes, you will be able to set up Santosh. There will be no issues. Okay. Just drop us an email. The one with respect to Hadoop course, for you should drop an email at hadoop@nobigdata.com. Okay, hadoop@nobigdata.com. And in case you have any queries related to course, you can send reach us at nobigdata and so on. But I think reach us at nobigdata is good enough for now. You can just drop an email at reach us at nobigdata.com. Okay. Reach us at nobigdata would be your single point of contact. Okay. Dushan's question is, would the course be enough for Cloudera certification? Yes, the course will be enough. Our course is actually designed in that same manner. All right. So thank you very much, and I look forward to see you in my session. And if you have any doubt, stay connected. Stay connected. If you have any doubt, let us know. Okay. Thank you, Pradesh. I hope you like the session. Thank you, Tarak. I'm happy that you find it helpful. Wow. Thank you, Morgan. I'm actually flattered that you find it fantastic. Hi, Pradesh. Yes, please be in touch. Okay. Okay. Thank you, Murli. I'm happy that you found it helpful. All right. Thank you, Karthik. Glad that you very liked it. Thank you, Shasidhar. Happy that you liked it. And Karthik, stay in touch. Yes, all of you, please stay in touch. If you have any question, just give me. Uh, yep. Saksham's question is it batch wise? It's sort of batch wise. Okay, when we discuss into detail about MapReduce architecture, you will realize that Hadoop MapReduce is more or less batch wise. Okay, thank you, Saurav, that you found explanations lucid. Yes, of course. Dushyant's question is, do you provide post-course assistant for doubts clearing? Of course. Once you are a part of our No Big Data family, you are forever there. Okay. We keep all of our students very much connected together. Okay. If you have any questions, anything at all, we keep in touch. Any batch starting in March? Yes, there is. I think batch starting in March. You can have a look at our our Okay, so I think there is a batch starting in March. Yeah, no, actually, that's interesting. So because the both the batches are starting now. One is in 21st today, and other is starting next week. Therefore, and it takes 1.5 month to finish the course. Therefore, there is no batch starting in the March. Only in April. 4th April is the one, and 11th April is another. All right. Thank you, Siddharth. I'm happy that you found the course great and introduction. I'll look forward to have further interaction with you. And yeah. So feel free to get in touch if you have any doubts. We try our best to answer your questions as many as possible. All right. All right. Thank you very much. So I'll be sharing the video recording with all of the people, whether irrespective of whether you are going ahead with the course or not. Okay. 22nd tomorrow is the second session. Okay, will not be available for all the people. It will be available for only the people who have signed up. I was trying to answer Murli's question. Course material is immediately available. Yes. As soon as you enroll for the course, we make it available for you. The older recordings, the previous sessions recording plus course material is made immediately available along with the Java course as well as regular expression course. So you have ample amount of things to learn, ample amount of things you can do before starting the course, although none of that is mandatory. Okay, Prajesh. Chini's question is, while registering, it is asking for Open ID. Not really. There is something called register. You can provide your email ID and then get it. Okay. Open ID is a general open authentication. So Dushyant's question is, are all sessions online? Yes. In-person trainings we stopped. The performance of the people who attended physically, their performance in our exams or tests were very poor. So we stopped our in-person trainings absolutely completely. Okay. All right. Thank you very much. We are dot on time. We are doing good with respect to time. If you have any questions, just drop me an email or give me a call at my number. All right. Thank you very much. It was a great session, great set of audience, great set of questions. Good, good. So Murugan is signing up with the course. Good. See you in the session from tomorrow. All right. Thank you. Bye bye. All right. Great. I'm hanging up now and stay in touch. And if you have any questions, drop us an email at reachus@nobigdata. All right.